Hi, okay, welcome to session 8. There's your recap, which obviously is in the workbook. I'm going to disappear in a sec so that I can put this out a little bit bigger so it's easy for people to read if they're working from the screen. The answers will follow in the same way, and then we will get on to our next piece of learning. All right, so I will be back. Okay, so just pause at the right times for you. Okay, the main thing to watch out for there, I've highlighted in green, are your different units. Okay, now there's no reason why you couldn't have taken the 60 centimeters and turned that into meters 0.6 and worked with those numbers. There is quite often more than one way to do things. If you've got everything backing up how you did it, then it will be, it will be fine and you will get all the marks. So it's a bit of a weird one there. I can't show obviously every way a problem may be solved. So like I say, if you went to meters instead of centimeters like I did, and you've still got all your answer there, it's absolutely fine and you will get the marks. So that's the main thing. Okay, so we're going to take our work with circles into cylinders so that we start looking at the 3D shape, and we're going to be looking at the surface area and volume of a cylinder today. I'm going to start with surface area because I think surface area is there's a bit more involved, there's a little bit more work to do, so it's a little harder. So let's do the hard bit first and then we can finish off with the easy and we'll be like, that's easy. So a cylinder, what I've drawn on the screen here is the 3D shape and then the net of that 3D shape. So a cylinder has got the top and the bottom circles, and then it actually has a rectangle in the middle. And I kind of wanted to show the connection between the circles and that middle section. So I'm going to try and do it with a piece of paper. So if this was my cylinder, okay, let's say it's a baked bean tin, and this is the label around that tin. You can see that the label will make a circle when it's rolled up. And this circle is the top of the tin, okay? But it's also the circumference of the tin. So of course, when I take this label and I unwrap it from around the circle, around the tin, the circle has become a straight edge. So it's gone from being the top of the tin and being viewed as a circle to becoming the edge of a rectangle. So this edge of the rectangle uses circumference. So it uses that formula. So let's just highlight that on our example or on our notes here. So this circle will unwrap itself to create this edge. So if I'm having to find the surface area, which is the area of the entire shape, then I am going to be finding the top and the bottom, which is basically two circles. And I'm going to be finding the curved surface, or nothing wrong in thinking of it like the label, okay, which is one rectangle. And that rectangle has pi d as part of its working out. So the normal formula for finding the area of a rectangle is base times height. Well, when we're looking at it as coming from a cylinder, the base is by pi d. So if I didn't have that number, that's how I would find it, by the height. So that's kind of what's going on. Let's just see the whole thing in practice, all right? So let's just say I have a cylinder, and I'm going to say that this cylinder is 6 centimeters long and 5 centimeters up, okay? If I'm being asked to find the surface area, the first thing I would do is probably start with the top and the bottom, okay? So the top and the bottom is coming from the circle, and the area of a circle is pi r squared. So I've got to go to the diagram and get the r. I want r. When I come along, this bit here, this circle, is being linked to this number there. But that line is saying that it's stretching right the way across. So what I've actually been given is the diameter. I want the radius, so I half that, and I'm going to be doing pi times 3 squared, which is obviously 9 pi. I don't just want 1, I want 2. So I double it, which will give me 18 pi. And it's up to you what you do here. I quite like leaving it there. Leave it in terms of pi, because if I change it now, I'm going to have a decimal to work with. And I'm only halfway through the question. And you'll see what I mean by, if I just leave it there, it makes life really, really easy. So my top and my bottom is this. My label or my curve, and obviously you will use whatever language you feel is going to help you remember best, because this is what it's all about. We can teach you the methods, but you've got to have ways of it getting triggered when you're sat in that exam. And maybe just thinking in terms of label, if that helps you, you do that. It's absolutely fine. So the curve is obviously my rectangle with pi d as the base, and I've got a height of 5. So I'm going to be doing pi times the diameter, which is 6, times 5. That gives me 30 pi. So total surface area is the 18 pi from the top and the bottom, plus the 30 pi from the label. That is giving me 48 pi as an answer in terms of pi. And I've hardly had to grab my calculator. The numbers have been really easy to work with. And I have a final result of 48 pi. However, if I'm not being asked to leave it in terms of pi, then I'm going to need to press that S to D. And at this stage, so because I haven't put anything in the calculator yet, what I would actually do is put 48 times pi in. That would give me 48 pi on the screen. Then I would press my S to D, giving me 150.7954, on and on it goes. And you would round to whatever you're being asked to round to in the question. Okay. If you round halfway through, so let's say you did this, but you pressed S to D at this stage and got a decimal, and you press S to D at this stage and you get a decimal. If you round, that final adding stage could cause you to be like even just 1 decimal place out. And if you're out, you're out, and you will lose a mark for accuracy, okay? So if you're not doing this, but I would, because it's really simple, if you want to see the full number and work with the full numbers, keep at least 3 or 4 decimal places so you can't make that an error in your workings. All right. Okay, so that is our first example. We're going to do another one. I'm going to rub out, I think I might keep the cylinder just because it is, in fact, yeah, we won't go to that one. We'll do another one here first. So let's put that back in. And we'll put that in at 10 centimeters. We'll put that in at 6.8 centimeters. Okay, so have a go, hit pause and try and get that surface area for me. Okay, so my top and my bottom is 2 circles. Pi r squared, r is 5, so pi times 5 squared, but obviously I want 2 of those, which will give me 50 pi. So my top and my bottom is 50 pi. 5 squared is 25, and then 25 times 2 is 50. So that's where the 50 came from. I'm now going to do my label. Notice how I give myself things to help me. Do as much of this as you need to. In fact, the more you do, the easier it is to follow what stage you're at with your working out. So I know that that's pi d, and that is my height. So I've got pi times the diameter, which is 10, times the height, which is 6.8. I put all of that in, okay? 6.8 times 10 is 68. So I've got 68 pi. Total surface area will be my 50 pi, my top and my bottom, plus my 68 pi, which is giving me 118 pi. So put that into the calculator. If you haven't done any calculator work yet, you put that in, saying 68 times pi equals, screen will say 68 pi squashed together, and then you can S to D it to get your 370.7079. On and on it goes. It's centimeters squared because it's surface area, and you round to whatever you're told to round to. Okay, so hopefully that has gone pretty well, or certainly seeing it for a second time will have ironed out any errors that may have happened. So we will do another one. We'll do this one here. So I want you to hit pause and press play when you are ready. Okay, so surface area then. Top and the bottom is going to be pi r squared, and obviously doubled because I want 2 of them. I've been given the radius this time. So there's my circle. The radius is clearly given to me, which is quite nice. So I've got pi times 3.5 squared times 2, which comes out at 24.5 pi. My label or my curve, depending on how you're thinking of it, is obviously pi d times the height. This is where I need to be careful because obviously I have the radius, not the diameter. So I'm going to be doing pi times double 3.5 is 7, and then times by that 12, which is going to give me 84 pi. Add those together. So 24.5 pi plus 84 pi is 108.5, which gives me an answer of 340.862, and on it goes, centimeters squared, of course. All right, so that's finding the surface area. And obviously there is more to practice at the end of this. But what we're going to do now is we're going to go on to looking at the volume, okay? I'm going to stick with this same cylinder, okay? So the volume is the space inside, and the volume, if you did the prism, so course, grade 4 course, there was a lot in volume. In fact, everything was in that course apart from the cylinders, because I wanted to keep it with the circle work. But what we learned there was that volume was basically the front face of a shape, and that face could take any shape at all. So you have this front face, which I'll colour in, and obviously we've got a front face here of a circle. And then there's like this third length that changes a shape from being 2D to 3D. So that edge there, which is mirrored here, creates a prism. So I've gone from 2D to 3D. So this length I refer to as the third length. And our third length, it takes this cylinder from being just a circle to a cylinder. That length is this one here. So the way that I referred to the formula, which is slightly different to what you see in textbooks, was area of the front face times by the third length. That is how you find the volume of any 3D shape, no matter what its front face is. All the work is in the front face. All the work is in knowing how to do area. So if you're good at area, you can absolutely do volume, because it is nothing more than one extra calculation timesing in the third length. So for the volume of a cylinder, what I'm going to be doing is finding the area of the front face, so the area of the circle times by the third length. So what have we got? We've got pi r squared, which is pi times 3.5 squared times by the third length, which is 12. You throw that into your calculator, which is going to give you 147 pi s to d it, and you've got an answer of 461.8141, on and on it goes, centimeters cubed. And that's it. So you can see it's a lot easier than surface area, because it's one thing, not two separate things that you then have to add together. It's just one thing, in it goes, and you've got your answer. So volume of any 3D shape is the area of the front face times by the third length, the length that makes it 3D. And the front face is when you kind of slice through, like a loaf of bread, when you slice through, every face is identical. Okay, it's often referred to as a cross section in textbooks, but I feel it's easier, it certainly has been in my experience in the classroom, that students have coped better understanding it as a front face. So that's why I do that. Okay, so here is a have a go question. So I want you to find the volume, not the surface area this time, the volume of that cylinder. Off you go. Okay, so we have, and it's really worth looking at your diagram and taking in what you've got. We've got this information all the way across, which means we've got the diameter of the circle, and we've got a height here of 9. So my formula is the area of the front face times by the third length. Looking at the question, that means it's the area of the circle times by the third length. So it's pi r, which is half the diameter, so 3.6 squared, times by the third length, which is 9. And you get 366.43, on and on it goes. So 366.44 centimeters cubed, if it's to 2 decimal places. Okay, so hopefully it's going well. We're going to do one more, and then we're going to move on so that you can just take some time to practice this. So let's just clean all of this off so we can put some new numbers in. Let's say we've got 8 here. Actually, I'm going to do something else. I'm not going to give you a number. I'm going to give you H. And I'm going to say to you that the volume has already been worked out. The volume is 191 centimeters cubed. And you have to work out the height of the cylinder. So this is how they might make a question a little harder. It feels a lot harder, and I understand that. But what I want you to do is still want you to have a go. I want you to just think, right, what do I know? What do I know and how can I use it? Because that is all you've got. I'm not about to show you anything that you don't already know. I'm just going to be showing you how to pull it together. But I want you to see if you can yourself. So when it comes to you having a think, don't just think, what do I know? Actually think about writing it down so you can then think, well, how can I use it? You will struggle to think about how you can use something you can't see. So think about writing it down. Go as far as you can and hit play when you are ready. Okay, so I am reading a volume question. So the first thing that I would do is go, right, what do I know about volume? I know that the volume is the area of the front face times by the third length. I know that. Looking at the shape I've been given, I now know it's the area of the circle times by the third length, which in this case is H, and it's actually my problem. Okay, so I'm going to rewrite this so it looks a little bit different. So we're going to be doing pi r squared. So that is that bit there, written there, times by H, which is making that third length. So that's that bit there. And I'm also going to write that it equals 191, because it does. That is a fact. This area of front face times the third length, which is what this is here, equals 191, because that's what they told me there. So I know volume is equal to 191. Now, all I can do is just put in the bits I know. I've put the 191 in because I know that. I also know the radius, so I can put in that. So I've got pi times 4 squared. 4 squared is 16. So I've got 16 pi times by h equaling 191. Now I'm down to an equation where if I want to know what the letter is, I've got to get it on its own. So if you did the course with the solving equations, we did absolutely loads of this. If you want to know what something equals, you get it on its own, which means you get rid of everything else, move it to the other side of the equal sign, which we do by hopping. So I'm going to pick up my times 16 pi, and I'm going to divide by 16 pi. So h is equal to 191 divided by 16 pi, which is 3.8 to 1 decimal place. So 3.8 centimeters when you put that in the calculator. Now you might have put 16 pi and got that as an actual number here, which is fine. That same number is what you would divide by. It's still going to work out in the same way. So it is, I mean, it is harder without a shadow of a doubt. It's why it's in grade 5 and not in grade 4 with the rest of the volume and prism work. So surface area and volume of cylinder right at the top end of foundation. And if they do something like that to you, they really are testing you at the maximum limit of this grade. All right. Now, if you want to rewind and just watch that through one more time so that you can kind of see that unfolding again, that mightn't be a bad idea. We're going to go straight into practice. We're not worrying massively about that. I think that is, you should have sort of a couple of targets. Your targets should be that you can find the volume and you can find a surface area. You want to tick that off. They are the most common questions. If you can extend into this, if you are growing in confidence in a way that means that you can extend into this, then you should by all means do it. But if this is a stretch too far, don't worry and put all your energy into this and let the other side of this, go. So always surface area and finding the actual volume is your priority. Okay. So here are some questions. Again, they are in the workbook. I'm going to scroll through just slowly so that you can see it from the screen if that is how you prefer to do things. Read through, just carefully work through, and then look at the answers, marking as you go. All right. Well done. That is a big, high-end area of maths. So well done if you're following that. Remember, you can always go back through anything at any stage because you've got these, you know, for a long time to check back in with. So do use them more than once. I'm going to go. So I will see you next session. I'm just going to slowly scroll through everything and then I will end the tutorial. All right. Good luck with these questions.